We're going to start section 3.4 by going over some definitions about triangles. The first definition is called a median. A median is a line segment drawn from any vertex of a triangle to the midpoint of the opposite side. Every triangle has three medians coming from each one of the vertexes. Since a median is the midpoint of the other side, what we know is that it bisects that side into two congruent parts. So, as that line is drawn, you can then conclude that those sides will have congruencies. You might be asked, though, does the median bisect the angle? In this example, it might be a little bit hard to tell because it does appear as though those angles are congruent. But take a look at the second triangle. If we draw the bisection line to the other side, or the median to the other side, bisecting the side of the triangle, notice the angles from the vertex. You can hopefully see that that first angle is significantly larger than the other. So, does the angle bisect? Does the median bisect the angle? Not necessarily. The next definition we'll talk about is an altitude. An altitude is a line segment drawn from the vertex to the opposite side, perpendicular to that. If you look at the altitudes drawn in the first triangle, you'll notice that the altitude will create perpendicular angles, or right angles. If you look on the longer sides, you can clearly see that an altitude does not necessarily bisect the side, but sometimes it will. It does appear as though this tall altitude does bisect those sides. So it could happen, but it won't necessarily be true. Another thing you should know about altitudes is that the line segment drawn to the opposite side doesn't necessarily have to be within the triangle. If we look at this triangle over here, and we try to find the altitude from this angle, it actually goes outside of the triangle to make a 90-degree angle. The last definition we'll look at is an auxiliary line. An auxiliary line can be very helpful when we're trying to maybe use a reflexive property or just need a little bit more to our diagram. What an auxiliary line is a line that we're going to draw and add to the diagram itself. So in triangle ABC, we could draw an auxiliary line connecting A to D, and the reason why we can do so is the postulate 2 points determine a line. Let's look at our first proof. Given angle T is congruent to angle Y, angle SVZ is congruent to SXZ, and that TV is congruent to YX, we need to conclude that line segment SZ is a median to line segment TY. After marking your diagram, you should really go back to your conclusion and see what they're trying to ask and what are some possibilities to get there. For SC to be a median to TY, what we know based on our definition of median is that TY would be bisected, so that TZ will have to be congruent to ZY. In order for that to happen, a couple of things would need to be true. One is that VTZ could be congruent to XYZ because TZ is a part of that triangle, as is ZY. Triangle STZ could also be congruent to triangle SYZ if we're trying to get the line segments, because those line segments are also a part of those triangles. What you need now to do is to look at the diagram and figure out which triangles would be easiest to prove congruent based on what's already been given. We already have angle T congruent to angle Y, meaning we know that one set of angles is already congruent. Both those angles are in both the triangles. The next thing that we already know is that VT is congruent to XY. That takes care of a side of the smaller triangle. So now what we need to figure out is, can we get those little triangles to be congruent? Based on knowing that these angles are already congruent, it should be pretty easy for us to say that this angle here and this angle is here based on the supplementary theorems. So we'll start with our givens. Angle T congruent to angle Y, angle SVZ congruent to angle SXZ, line segment TV congruent to YX. We'll then state that the angles SVZ is supplementary to angle TVZ and angle SXZ is supplementary to the angle YXZ. Reasoning: if two angles form straight angles, then they are supplementary. Since we know that those angles are congruent in the given and that they're supplementary, we can then prove that angle TVZ and angle YXZ are going to be congruent, based on the theorem that supplements of congruent angles are congruent. Once we prove the angles to be congruent, we have now enough information to prove that the yellow triangles are congruent, based on angle, side, angle postulate. Now that we know that the triangles are congruent, we can then say that TZ is congruent to YZ based on corresponding parts of congruent triangles being congruent. Now, since we've established that those are congruent, that can go and lead us right to our conclusion that SC is a median to TY based on the reasoning or definition of a median. If a segment from a vertex of an angle divides the opposite side into two congruent segments, it is then a median.